you had an acid, HBr, and that hydrobromic acid had a molar concentration of 1.45 molar. And then you were supposed to find the hydrogen ion concentration, hydroxide ion concentration, pH, and pOH. Okay, I may not have listed in the same order in the problem, but it doesn't really matter. Now, there's more than one way to get this. You don't have to do it the way that I'm going to do it here. You can do it in a number of different ways. If you look on page 26 of your unit handout, Unit 9 handout, you can go in either one of the two directions from any point. What? Yeah. All right. I need your attention here. I need your mouth to be closed up. I need your mouth to be closed up.
Did you already ask me?
I did.
Oh, I think he wasn't paying attention.
Apparently not. I said no more late work.
Oh, you did?
You were right there, but you were just talking away when I asked you to be quiet.
Not necessarily. Yeah, it is necessary.
Okay. Time to be quiet and pay attention, please. All right, since HBr is one of those 7 strong acids that you have to know about, and since it's monoprotic, since this is one of the 7 strong acids you're supposed to know about, it's in your unit handout, the list of them, and since it's monoprotic, the concentration of HBr, the molar concentration of HBr, is the same as the molar concentration of the hydrogen ion. Yes? Mm-hmm. Why don't you wait till she has to go to... Where did she go? I know, but she went. I thought she went to just get some water. I understand, but she didn't take the bathroom pass. She asked me, could I go to the bath get some water? She wanted some water. Yes, you get some water if you'll go right across the hall here and get some water, okay? So the molar concentration of the hydrogen ion is 1.45. Where'd you go?
That water high. I am a little thirsty.
And I understand you were working hard there, but I need, you know. All right. So that answers one of your questions right there. That's about as simple as you can get. So that's H plus, we got that one, that concentration. Let's see. From the H plus, I can get the OH concentration or the pH. Okay, and it doesn't matter which way you go. If I want to get the OH concentration first, I would use this equation. Where Kw is always 1.00 times 10 to the negative 14 molar squared. And H plus we know is 1.45 molar. And so we're trying to find the OH concentration. To isolate the unknown, we simply divide both sides by 1.45 molar. Okay? And when we do that, this whole thing cancels here. And we just have to divide this number by that number. Yes. You don't want to see how this problem is solved first and take notes?
Try to think what's going to say.
Huh? Yeah. Now you have to know how your calculator works. We practiced a little bit with that yesterday. Every calculator in this room will get all of these answers. If you didn't practice yesterday, then maybe you don't know how to make it work. Practice, practice, practice until you learn how to make your calculator work, until you can talk its language. So this is how I put it in my calculator. It might not be the way it's put into yours. And your calculator may have to sort of back into the answer. All right, so I get let's see, 6.89, 655, 172 times 10 to the negative 15. Okay, and that's the OH concentration, the hydroxide ion concentration. So now I need to underline the insignificant digits. Well, I have 3 digits in this number and 3 in this one. So I'm going to just keep 3 digits in the final answer, underlining from here over. And I get an answer that's 6. This 6 makes the 9 round up to 10, which makes this a 9. So 6.90 times 10 to the negative 15. And let's see, actually this is molar is the answer. Okay? So that's that answer. From that answer then I can get pOH. Or I can go back to this amount here and find the pH. Okay? Let's find the pOH from this number. pOH is equal to the negative logarithm of this OH ion concentration. So that's the negative log of 6.90 times 10 to the negative 15. Now, in my calculator, I can put the problem in exactly the way it reads. But in your calculator, you may have to back into it and put in this number first, then click your log key, then hit your change of sign button. Let's see. See if I have a calculator where I have to back into the problem. I think this is one where you have to back into it here. So I think I have to put in 6.90 double E 15 and change the sign. I hit equals. Then I'm going to do the logarithm. Where's the logarithm? There we go, logarithm. And then change the sign down here at the bottom. Okay, to get the answer. So this is one of the type of calculators where you have to sort of back into the answers here to solve these problems. Okay. So the pOH starts out as 14.16115091, and using the rules that we're going to use for rounding, we're going to use the same rules as multiplication and division. There is a set of rules, a special set of rules for logarithms and exponents, but we don't use it in this class. We're just going to use multiplication and division rules, so we're going to keep the same number of digits as we have here. And we get 14.2 is our pOH. Okay, so now we've got this answer. Got that answer right there. Well, now that we've got this, we can calculate the pH either from this amount or from that. Okay? If we have the pOH first, we know that 14 is always equal to the pH plus the pOH. So by putting in the pOH here, 14.00 equals the pH plus 14.2, and then we want to subtract 14.2 from both sides. We have pH by itself over here because that completely cancels out. It's completely subtracted out. And this is 0.2. So pH is 0.2. Alright? So now let's calculate the pH from the hydrogen ion concentration to see what we get. Doing it that way, pH is equal to the negative logarithm of the hydrogen ion concentration, which is equal to the negative logarithm of 1.45. Okay, and I get a negative, I'm sorry, this should be a negative 0.2 here. I get a negative 0.1613680022. We round that off to 3 digits, and we're going to get negative 0.161 as our pH. Okay. All right. Now that's not quite the same, but it's a rounding error based on the way that we're doing things here. Okay. And I would accept either one of these answers if you justify your answer through your work. Okay. But if we were to round this to only one significant digit, it would be the number 2, wouldn't it? So it's mathematically reasonably close. Okay? Any questions about that? Alright, so using that graph, or graphic, I think it's on page 26 of your handout. Yep. Okay, you can go from any one of these values to any of the others. Okay, you just got to go around this way. You can't go across the center of it, you got to go around it. Alright? Sure. You can go in either direction or you can go both directions. I mean, if I was starting like I did here with the hydrogen ion concentration, I can find the hydroxide this way. And I can go down here and find pH then pOH if I wanted to. I don't have to go around all the way around one direction. I can go part way this way and part way that way to get all the answers.